and welcome back for day 2 of graphing quadratics. So we are going to move on to a new way of solving these types of problems. This one we are going to be graphing given some information and writing equations. So remember, the form for vertex form of a quadratic is a times x minus h squared plus k, where our vertex is hk. So here we're given our vertex. So here we already know that h is -3 and k is +3. And then we're given one point that this parabola contains. So if we look at our equation in vertex form, the things that we need are a, h, and k. So if we already have h and k, we just need to solve for a, and we can do that using this point. So here's our x, and this is our y, or our f of x. So we can plug in h and k, we can plug in x and f of x, and solve for a. So f of x, 1, is equal to a, because that's what we're solving for. X is -2 minus h, which is -3, squared, plus k, which is 3. And we're solving for a. So I have minus a negative, so that becomes plus. So -2 plus 3 is +1. 1 squared is just 1. And I'm going to go ahead and move this 3 to the other side. So we're going to get that -2 is equal to a. So if a is -2, the equation of our parabola is going to be f of x is equal to -2 times x, and remember, because h is -3, that's going to be x plus 3 squared plus 3. All right. Now on B, we're given the vertex and a. So all we need to do is plug in those values into our vertex form equation, because we know this is h, this is k, and it tells us a is -1. So f of x is going to be negative x. Remember, if h is negative, that's going to become plus 3 squared plus 4. And that one was pretty easy. All right, now on the back, we're just going to be sketching some quick graphs. And this, we can actually use what we know about transformations of parent functions to graph them. So starting with x, or y equals x squared, this is our parent function of our standard parabola that is open upward. So we are going to use that starting point to then use what we now know about parabolas to sketch these transformed parabolas with equations in vertex form. So starting with number 2 here, our h is 4, and because we don't have a number out here, we can assume that k is 0. So that tells us that our vertex is going to be 4, 0, and it's open upward. So I'm going to go over to 1, 2, 3, 4. We can just mark that ourselves. And it's open upward. Now, if you think back to the very beginning of the year when we learned about transformations, this is a horizontal shift to the right 4. So from our parent function, we went to the right 4. That matches where our vertex is using our vertex form. Now, let's see that happen again. On 3, we have the same thing, except that our k value is 6. So that means our vertex is going to be at 4, 6. And it's still open up. So I'm just going to 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Mark this myself. And if you think back to our transformations, again, that is a shift horizontally to the right 4 and a vertical shift up 6. And that's where my vertex of my parabola is. Okay. On 4, my vertex is going to be -5, -2. And again, it's still open upward. So 1, 2, 3, 4, 5, 1, 2. So this matches with our transformations of a vertical shift to the left 5 and down 2. That matches where my vertex ended up. Okay. And last but not least, I'm going to start by finding my vertex, and that's going to be at -2, 3. So -2, 1, 2, 3. There's my vertex. And because a is -1 here, that means that my parabola is going to open downward. So my vertex is at -2, 3, vertical shift to the left 2, and horizontal shift to the left 2, vertical shift up 3, and it's open downward. That means this is a reflection across the x-axis, and that is consistent with my transformations we learned early in the year. So, and that is it. That is the end of our notes for day 2.